All right, hello everyone. So I'm Robert Ritz, and the topic of my talk today is how data science can help solve air pollution in Ulaanbaatar. It's a project I've been working on for a few years now. Things have been changing, and as data does, and hopefully I'll be able to share some of my thoughts on this. Air pollution is a, a problem in Ulaanbaatar, as you all know, but it's also a problem in a lot of other cities in Mongolia. And even with the recent change to the other type of fuel, the processed coal, air pollution is still a problem. We're seeing a reduction in air pollution and PM 2.5 numbers, but it's still well above the WHO recommended levels. Um, but I'm not here to talk about air pollution exactly. I'm here to talk about the data and the data science behind it. So air pollution is a unique problem for data science because, well, there's a lot of different types of data. You have geospatial data, so each weather station and each pollution station is on a latitude and longitude grid. And then in addition, you have mountains and hills and roads and buildings in Ulaanbaatar that make it quite interesting to measure and to model. And then you also have time series data. So not only do you have the data spread around geospatially, but you have it over time. And Mongolia is also really interesting because the weather is really variable from day to night and from different seasons. And it's a different task than most data science tasks because, well, it's the number one problem is sparse data. So what I mean by sparse data is that, well, the stations can sometimes go down for hours or for days, which means you have pretty large gaps in your data set. And when you're dealing time series modeling, that becomes a really big challenge when you're missing part of your data. But not only that, but it's also you don't have the measurements in between the air pollution stations. You only have the air pollution stations themselves. And so if you want to model the data between them, you have to do some estimation and some guessing. And on top of that, even though the air quality stations in Ulaanbaatar are quite good, sometimes they produce inaccurate measurements, just like any sensors that you might expect. This is no different than if you were monitoring a server farm and you were trying to do analytics on the servers themselves. You would have some occasional errors in the sensors. And so you might have really, really high values, really, really low values, or really spiky values that are not really accurate. So all of those make this a different challenge than a lot that you'll see. So let's actually really talk about the real problem here, which is that air pollution is actually really caused by individuals, right? So the majority of air pollution in Ulaanbaatar is not created by power stations, it's not created by cars, it's created by homes and burning coal, eat whatever the type of coal it is, for heat and for cooking. So this is really, it's a macro problem because it impacts everyone, but the cause is a micro cause. So what I want to talk about today is why, while the government is actually producing a macro solution by changing fuel, getting restrictions, lowering electricity prices, or making them free during the evenings, the cause is a micro cause. So what I really focused on is coming up with micro solutions to the problem that'll hopefully help individuals make better choices and make them aware of their situation so that they can help solve the problem. And it's not just the government's responsibility to solve it. So, but it's not always that easy. There are some major roadblocks when you're trying to solve a problem like this, or at least help a problem like this. The number one issue is there's a lot of closed data around air pollution or semi-closed data. In data science, you need a lot of data. I mean, that's like no surprise there. And one of the biggest issues is that the government air quality sensors don't have a public API and they don't have a centralized data repository to access all of the data. So Agarmongolai, which is where you can access the readings from the government air quality sensors, there's no API there, at least no public API. There is a company called AirVisual that hosts data for more than 10 air quality sensors that were installed by the European Union through an NGO here. And they have a lot of data for these sensors, and they're quite accurate, and they're geographically spread around. But the data goes back only to mid-2019, which is a pretty big problem. And there's no official historic data source for all of the air quality sensors in the country. There is another air quality station, it's only one, that's hosted by the US Embassy, and they actually just drop CSV files on their website and allow you to download them. So it's a really big mix, and a lot of the data isn't open. So there are some solutions that I came up with for this. One is, well, if you can't have one data source, then you have to combine multiple data sources. So prior to March 2019, and this is when I'll talk about the next problem, but there was an NGO, an international NGO called openaq.org. They actually were hosting air quality data for Mongolia. And so you can access agar.mn and statair.mn data prior to March 2019 on that site. However, after March 2019, they stopped collecting data, and I'll explain why in just a minute. Now, after March 2019, what I've been doing, because OpenAQ no longer collects it, I've been essentially scraping the website and collecting the data myself so that we actually have a record. And then I already mentioned StateAir, and then AirVisual, they have an API, and they've been really good about giving access to this API. So that's one problem. And here you can see a map of all of the air quality stations in the city. They're pretty well distributed. You can see the blue dots are Agar.mn. The orange is Tsagagar. This is a little bit of a problem because these are managed by the meteorology agency. They don't measure particulate matter pollution, but only what are called volatile organic compounds, or SVOC, semi-volatile organic compounds. So those aren't particularly useful for measuring particulate matter pollution. And you can see the new ones, the pink ones, that were installed by People in Need, which is an NGO connected to the European Union. So the next roadblock was how do we manage the new Mongolian air quality standard that was established in 2018 and actually implemented in 2019. So what they did, the Mongolian Ministry of Environment, they actually changed the air quality reporting standard especially for particulate matter pollution. The biggest difference is they moved from a 1-hour average to a 3-hour moving average. And so if you've ever done any smoothing or time series modeling or exponential forecasting or things like that, you'll know that as you do weighted averages or moving averages, you tend to smooth trends out. And so this is what happens. You can see the chart down here. The blue line is the old US AQI standard, and the orange line is the new Mongolian AQI standard. And if you look at it hourly, you can see that that the orange line here is lower. So it makes it look like the air quality is actually better than it is. But the reality is that this is the same sensor data. So the data coming from the sensor is exactly the same, just the way that you calculate AQI is different. So luckily, though, a big benefit is that if you look at the daily averages or monthly averages, it doesn't actually impact it that much. But if you look at the hourly averages, this is where the big problem is. So this is a really big problem because now we have two different standards. And if you're comparing data from this year and you want to look at 2 years ago, you can't directly compare them. You have to convert them over to a common standard. And the problem is because you're like super sampling, that's what it's called. You're actually taking a 3-hour moving average. It's difficult to subsample from that. So you actually can't really accurately go backwards from the Mongolian standard to the US standard. So you actually have to move everything from the US standard to the Mongolian standard to make it comparable. And so that's a huge thing that I had to do to make this analysis work correctly. So the solution that I've put together is, at least one of the solutions, is Agar.Mongol.ai. And this is basically just a dashboard, if you will. It's an interactive dashboard that allows you to look at air quality data going back to 2015 for all the air pollution stations that have been active for many years. And what you can see is, this is the year view. Definitely, the winter of 2019 and spring of 2020 has been lower than last year, which is good news, right? And you can also, though, break it down by month or day. And this is the day view. And the day view is tricky, though, because it's difficult Like if you were in consumer forecasting or consumer sales, you would just look at the same day last year. Or if you were looking at sagansar, you would look at last sagansar. But you can't really do this with weather because weather changes and you can't guarantee that the weather is the same every day. So I built a quick little algorithm that uses cosine similarity to compare days so that you can actually say, well, these are similar weather days to this day in question. So we can actually compare air quality using similar weather days, which is quite nice. And this is just one example from the M&B station from January 30th. And you can see that that the air quality is better than 2016, November 17th, 2016, which had very similar weather. But you can also see 2 days that were much better. But then you can look at the weather down below and see that the real reason why these 2 days were significantly better was that the wind speed was higher by about 2 meters per second. And this really gives you an idea of, and it starts to help you explain why air pollution actually is as variable as it is. So this is a good solution because it allows you to look at the past. But that's not really what I think is the best solution. So I've come up with 3 other things that I want to quickly tell you about that I think will help going forward to help solve this problem. And they all use data science. The first one is pollution forecasts. The second is hyperlocal pollution data. And then a messenger chatbot or an SMS platform. A pollution forecast is going to be great because it can give you actionable information, just like a weather app. Hyperlocal pollution data can actually make it to where you can see what the pollution is like near you. And the messenger bot is great because it opens it up for everyone to use in a format that they're comfortable with. So I did an experiment in 2018, 2019 to actually forecast PM 2.5 using only one station. And well, to be honest, the results weren't great. When we were using our blind sample, we got an RMSE of about 50. But then when we actually deployed it to production, it was around 100 for 1 hour ahead. And so what we learned from this was that, and I worked with this with some of my students, there's a huge number of factors that impact air pollution. So it's humidity, temperature, wind speed, wind direction. It could also be things like how close is the weather or the quality station to a road? Is there a mountain nearby? Where is it on the mountain, right? All of these things can impact it. And if you were actually doing analytics for a server, you would say, well, the server next door doesn't impact this server. But it's not the way that this works for air quality sensors because pollution actually moves, right? So wind is blowing the pollution around. So you need to get a whole picture of where pollution is coming from and where pollution is going. And on top of that, there was data inconsistencies, which are really difficult to manage. And so all of that meant that the results weren't perfect. But I do hope to have version 2 ready by the next fall, so that we'll hopefully be able to have some better results. The next thing that I think would be really great to have is hyperlocal pollution information. And what we'd have to do here is actually interpolate the air quality between the stations so that you can actually make something like a heat map, which you can see here, which is, this is actually a map of sound pollution in New York City. And they estimated the sound pollution in these areas based on a variety of factors. And there's many different ways to do this, but it's all using geospatial data combined with the air quality data. This will allow you to say, well, hey, what's the air quality like in my building? So if you're far from a station or you're in between 2 stations and you're not sure which one to pay attention to, it'll give you a better, more accurate view of the reality. And then the last one is a messenger bot or SMS. So, all the apps right now are designed for you to go out and get the data. And well, to be honest, who wants to go out and look at depressing data, right? No one wants to go out and do that. So it's better to actually bring the data to the person, right? In the middle of winter, I don't know about you, but I almost never check my weather app because it's going to be cold, it's going to be polluted. So why are you going to check, right? And so weather apps are a pull-based approach. And messenger bots, though, are push-based because you can subscribe to them. And so you can do things like get bad pollution alerts, get forecasts pushed to you on a schedule that you choose, or even relevant tips from government ministries or NGOs that can help you protect yourself from air pollution. So these three solutions, I think, are going to be really useful in sort of moving forward with not just solving it on the macro level, but also on a micro level. So thank you for your attention.